Hello everyone, welcome back. Today we are diving into one of the most important concepts in automata theory, NFA to DFA conversion, which forms the base of the compiler. This process is foundational for building our efficient compilers because it takes the flexible structure of the NFA, that is your non-deterministic finite automata, and turns it into a deterministic finite automata, that is DFA, which is more straightforward for the compiler to process. Let's start with a quick recap to the null closure. See, the null closure of any state, let's say state S. So the null closure of S is defined as all S belongs to the null closure of S. Let's say, for example, I want to find the null closure of A. Okay, so the first element in the null closure of A will be A itself. See, null closure is something that it is a set of states from which we can transit as by taking the null as an input symbol. Okay, for example, if this is my state A, okay, I want to find the null closure of A. Okay, what will be the null closure of A? So see, upon it consists the set of states upon which we reach when null is given an input, that is by zero transitions. Okay, see, if whenever I am getting, see, I am not doing any transition and I am transiting to this state itself, right? This is not actually, yeah, then also I'll be transiting to this state. So it is obvious that the state itself can transit to itself with zero transitions. So the state itself will be a part of this element of the null closure. So yes, then for all the elements which are belonging to this null closure of S, okay, that is null closure of S में belong करता है अगर ये सारे elements, okay, or the set of states. So any transition from which a set of state and a null exist, then they also belong to the null closure of S. That is, see, if A is a, let's calculate the null closure of A. Okay, see, the null closure of A will be what? So at which of the states we are transiting by taking null as an input? See, A to B. So yes, we can go from A to B using null. Yes, from, is there any state from B which we can transit to that using the null? So that is C. We can go from B to C. From C, is there exist any state? No. From B and any other state? D. Yes, so D. Now from D, can we go to any other state? No. From C we can go? No. So we just need to check all these elements, that is for all Q which belongs to this null closure, is there exist any transition such that Q comma null gives us a state. So A comma null gives us a state B. B already exists. B comma null gives you C. C comma null gives you nothing. D comma null gives you nothing. So this is how you find the null closure of any state. Okay, so now let's start with the conversion of NFA to DFA. We start this conversion, we'll follow the steps. The first step is to convert the regular expression to NFA, okay, and then we can convert this NFA to DFA. In the second step, we'll first find the null closure of the initial state. Okay, so we'll get some new state. After getting the new state, we will find the transition function of that new state. Okay, so whether there are input symbol, let's say 3 input symbols are there, then we will get 3 transition functions. So 3 new states will be formed. So then we will take the null closure of that resulting sets and we will repeat these steps until a new state is formed. And then we'll draw a transition table in the DFA. Okay, then let's understand these steps using the example. For example, this is my regular expression A or B, A, B, B. So our first step is to convert the regular expression to NFA using Thompson's rule, as we have studied in the earlier session. So first of all, A plus B star, right? How the A plus B will look? Some initial state which is joined with both A and B, and then it is joined with the final state. Okay. Then we have to do the stars. We have to introduce the new initial state, we have to introduce the new final state. Okay, but here we'll join, okay, and the initial and final state are being combined with null, and this will be combined with null. Okay, let's sequence it. 0 1 2 3 4 5 6 7. Okay, then it is A B B, so we just need to concat. So A B and B, this will be my final state, that is, let's say 10. Right, now what is our second step? Our second step is to find the null closure of, this is my initial state. Okay, null closure of initial state. So my initial state is what? 0. So let's find the null closure of 0. See, from 0 to null we are getting 1. From 1 to null we are getting 2 and 4. 2 and 4. From 2 are we getting any null state? No. From 4 are we getting any null state? No. From 0 we are getting to 7. From 7 are we getting any null state? No. And 0 itself. The 0 1 2 4 7 is the null closure of initial state. So let's name it as capital A. So 0 1 2 4 and 7. Then our next step is to find the transition function of the resulting set. So what we need to find is A comma whatever are our input symbols, that is A and B. So we will do transition function of A and delta A comma B. So what it will be? First of all, it will be 0 comma A union delta of 1 comma A union delta of 2 comma A union delta of 4 comma A union delta of 7 comma A. Similarly here, delta of 0 comma B, because we have to find for each element. So delta of 1 comma B union delta of 2 comma B union delta of 4 comma B union delta of 7 comma B. Now let's calculate 0 comma A. Delta of 0 comma A, from 0 on input string A, can we go to any other state? No. So that is 5 union 1 comma A. From 1 can we go to somewhere using A? No. So that is also 5 union 2 comma A. So from 2 and A we can go to 3. So it is 3. Is there any other state from where? No. Then 4 comma A. So from 4 using A? No. So that is also 5. Then 7 comma A. So from 7 can we go in? Yes, from A. So it is 8, right? So it gives you 3 comma 8. Similarly, let's check for B. So 0 comma B, no. Then what we have? 1. 1 comma B, no. 2, 4 and 7. Let's check for 2. No. For 4 it is 5. So 5. Then 7, no. Okay, so only 5. Let's name it as, let's name this. Okay, so let's name them as a resulting sets. Now we need to find the resulting sets of null closure of this resulting sets in the step 4. So in step 4 what we do? We find the null closure of this resulting sets. So the null closure of 3 comma 8 is null closure of 3 union null closure of 8. Now what will be null closure of 3? First of all 3 itself, and same way first of all 8 itself. Let's calculate from 3. From 3 to null we are going to 6, and from 6 to null we are going to 7. So 3, 6 and 7. From 7 are we going anywhere? No. And we are from 6 we are going to 7, and from 6 we are going to 1. From 1 we are going to 2 and 4. So 3, 6, 7, 1, 2 and 4. Okay, so 3, 6, 7, 3, 6, 7, 1, 2 and 4. And for 8, let's see for 8, from 8. So for calculating the null closure of 8, there is no null transition from 8. Okay, so the null closure of 8 will be 8. itself. So from union we'll get 1, 2, 3, 4, 6, 7 and 8. Similarly for finding the null closure of S, so null closure of 5, so from 5 we can go to 6, from 6 we can go to 7, then 1, 2 and 4. So 5, 6, 7, 1, 2 and 4. So 5, 6, 7, 1, 2 and 4, that is 1, 2, 4, 5, 6, 7. Let's name this state as C and let's name this set as P. So we have completed the step 4, that is finding the null closure of the resulting sets and naming this. Now we have to repeat these steps until we find no new state, but we have found this 2 new state, so you need to repeat the first 4 steps for these 2 states also. Let's now continue for the same steps for our new states, that is B and C. So whatever our new states 1, 2, 3, 4, 5, 6, 7, 8 and 1, 2, 4, 5, 6 and 7. So first we need to calculate B comma A, B comma B, C comma and C comma B. We need to calculate the transition functions and find the null closure of the resulting sets. So from B to A, first we'll find out. Let's draw the diagram again here so we can get the. So this is our 0 state, this is our 1 state, 2, 4, 3, 5, 6, A, B, null. Then we transit to 7 using null. Then we transit to 8 using A, B. Okay, and from this to this null, and from 6 to 1. This was our diagram. Okay, let's first find out 1 comma A. So 1 comma, is there anything? First what we need to find out, that is delta B comma A and delta B comma B, delta C comma A and delta C comma B. This is important. First let's find out delta B comma A. In set B what we have is 1, 2, 3, 4, 6, 7, 8. So first of all 1, no, 2, yes, we get 3, 1, 2, 4, 1, 2, 3, 4. Okay, 1 we have already seen for 1, we have already seen for 2. Now let's see for 3. Is there any transition by A? No. Then what we have 4, 6, 7. From 4 is there any transition with A? No. From 6, no. From 7, yes, we have it as 8. So 3 comma 8. Then from 8 we have any transition? No. So 3 comma 8. Let's calculate for B comma B. So from 1 to B, no. What we had 1, 2, 3, 4. So from 1 to B, no. 2 to B, no. 3 with B, no. 4 with B, yes. We'll get 5. Then what we had in the B, that is 6, 7, 8. So from 6, no. From 7, no. But from 8, yes, B. So we'll get 5 comma 9. Now let's find out the null closure of this both. So null closure of 3 comma 8 we already found the null closure of 3 comma 8, that was B. Now let's find the null closure of 5 comma 9. We already know the null closure of 5 and it will do the union of null closure of 9. Null closure of 5 was what? Our set C. Okay, so set C was what? 1, 2, 4, 5, 6 and 7. When we see the null closure of 9, it is itself, right? Null closure of 9 is itself. So here we will do the union with 9. So it is 1, 2, 4, 5, 6, 7 and 9. Okay, let's name it as D. Now let's find out C comma A. Now what we have in C, so 1, 2, 4, 5, 6, 7. So 1 with C, 1 with A, no. 2 with A, yes. So we'll get as 3. Then 1, 2, 4, 5, 6, 7, 8. So 4, no. 5, no. 6, no. 7 with 8, yes. So this is 8. Then C comma B. So C we have 1, 2, 4, 5, 6, 7. So 1 with B, no. 2 with B, no. 3 with B. We are finding for C, right? 1, 2, 4, 5, 6, 7. So 1, 2. So we are finding for B, transition for B, right? So we can transit to any other state using B from 4. Yes, so 5. that is 5. Now let's see for 6 and 7. So from 6 no, from 7 no, so that is 5 itself. So let's find the null closure of 3, 8. Null closure of 3, 8 we already found, that is B, and null closure of 5 we already found as C. So B, now from the resulting sets after the null closure, we have found that only the D is the new state. This B and C already exist. So let's find delta D comma A and delta D comma B. 1 2 4 5 6 7 9, right? Let's start with 1. So 1 to A, no. Then what we have? 2 4 5 2, so that is our 3. Then 4 5. In 4 we get 4 no, 5 no, 6 no, 7 yes, we get as 8. So we'll write here as 8. Then what we have is 9. From 9 A, no. Now let's see for B, transition functions for B. So 1 and B, no. 2 with B, no. 4 with B, yes, we get as 5. This was a transition function of 4 comma B is 5. Now what we had? 6 comma B. So 6 comma B, no. 7 comma B, no. 9 comma B, yes, that is 10. So that is 10. Now let's find the null closure of this 3 comma 8. We have already found, that is B. Null closure of 5 comma 10. Null closure of 5 we already had. What was that? B, which is 1 2 3 4 6 7 8. And null closure of 10. Null closure of 10 is nothing but 10. So we'll do union directly, that is 10. So this is my new state. Let's name it as E. So now we need to find out the delta E comma A and delta E comma B. What was my E? E was my 1 2 3 4. Okay, 1 2 3 4 5 6 7 and 10. Okay, so there was one. Yeah, what we have done here is null closure of 5 instead of null closure of 5 was C. Instead that we have written of B. So let's correct it. It is 1 2 4 5 6 7. Okay, so 1 2 4 5 6 7. This 8 will not be there. Okay, so 1 2 4 1 2 4 5 6 7. Okay, so we'll introduce a 5 here. Let's do this. 1 2 4 5 6 7 and 10. Okay, so this will be my new state E. So it is 1 2 4 5 6 7 9 and 10. Okay, so let's calculate E comma A. So it is 1. See, 1 comma A was nothing, 2 comma A was nothing, 4 comma A was nothing, 5 comma A was also nothing, but 2 comma A was, we already only had 3 comma 8 as A, right? So 3 comma 8. Then for delta E comma B, so we only had a transition of 4 to 5 and we had the input symbol as E, so 5, and from 4 to 5 and 8 to 9 and 9 to 10. So we don't have here 8 and 9, so it will be 5 only. Now let's calculate the null closure of 3 comma 8. We already know the null closure of 3 comma 8 is B and null closure of 5 is equal to C. So no new state is being introduced. So let's go to the step number 5, that is transition table. Okay, see, transition table is formed by states and input symbols, that is A and B, for which we have found this transition functions, right? So the first state which we got was A. What was A? The A was 0, 1, 2, 4, 7. Okay, so it is 0, 1, 2, 4 and 7, and the new states which were introduced from transition function of A and B was B and C. Then for this B, we had 1, 2, 3, 4, 6, 7 and 8, right? 1, 2, 3, 4, 6, 7 and 8. 1, 2, 4, 5, 6, 7. For C we had 1, 2, 4, 5, 6 and 7. See, from B we got B and D. And what was D? D was 1, 2, 4, 5, 6, 7, 9, right? 1, 2, 4, 5, 6, 7 and 9. From C we got B and C, and from D we get B and E, and from E we got the states B and C, B and C. And what was our E? E was 1, 2, 4, 5, 6, 7 and 10. Okay, so this is my transition table. See, after this transition function or transition table, we have formed the DFA. See, from A we can go to B using A, and we can go to C using B. To C using B. Similarly, from B we can go to B itself using A and D using B. From C we can go to B and C, so from using the A and B. Then from D we can go to B and E, so from D we can go to B using A and E using B. Same way, from E we can go to B and C. From E we can go to B using A and C using B. So this is my DFA. Now while deciding the final state, we have to see and question that what we had the final state as 10, and 10 is an element of which set? 10 is an element of E. So we have marked E as an accepting state or final state. So that's it for NFA to DFA conversion. So this process might seem complex initially, but once you practice it, you will see that it is just a systematic way of removing the ambiguity and creating a clear path for each input. So in our next session, we'll explore DFA optimization, a process that helps to reduce the DFA even further by removing some redundant states. So thank you for watching. If you have any questions about NFA to DFA conversion or any concepts that we have discussed till now, feel free to comment below. See you all in the next video. Thank you.